Well, here we go. We got a twin 4A test coming up. And I got a little bit of break time here, so let's go over the bonuses. Let's also make sure this thing can hear me. Good, it can. If theta is a third quadrant angle with the cosine ratio being -7/12, so what is the value of tangent? So this will be new to y'all. You guys didn't learn the things that are actually quite in your standards last year, and I understand why. I used to teach geometry, and there's just some things we didn't teach some years, just depending on the kids we had. And we'll talk about y'all. Yeah, pretty rough. Anyways, the deal is we draw a triangle in quadrant 3. Quadrants, by the way, go 1, 2, 3, followed by 4. Now, the way you draw is important. The angle always is at the origin. From SOHCAHTOA, I know that cosine is adjacent over hypotenuse. There's a negative symbol here. The hypotenuses are always positive, and there's that. Your missing leg, which I'll just call A, can be found using a squared plus b squared equals c squared. So I don't know A, but I know B is -7. This is actually one of those special Pythagorean triples too. So a squared plus a -7 squared is 12 squared. A squared plus 49 is 144. I guess I'm wrong. It's not a special pattern. If you subtract 49, I think you get 95. Interesting. So A is root 95. No, anyways, root 95. Root 95 does not simplify. Root 95 is 5 times 19. Its only factors are primes. So anyways, this is now root 95. Direction is important. It is falling, so it's negative. So the tangent of this angle has to be opposite over adjacent. Opposite is a negative root 95. Adjacent is a -7. It ends up being positive root 95 over 7. Ta-da! Quadratic function in the form ax squared plus bx plus c. Every time that I hear the word quadratic, I literally sing in my head, x equals -b plus or minus square root b squared minus 4ac all over 2a. The reason I circled opposite b over 2a is because of this. I know that this 3 is equal to opposite b over twice a. That's what I know. That's what I know. So let's make this look like b over 2a. We're going to multiply the negativity out. That'll give me -3 equals b over 2a. And then we're going to multiply the 2 out. -6. -6 equals b over a. Easy peasy, Japanesey. All right, what are the real solutions to x to the 2/3 minus 1 equals x to the 1/3? We're going to use a technique called U substitution. I'm going to let u equal x to the 1/3. Therefore, u squared would be x to the 2/3. So this becomes a u squared minus 1, and that becomes u. Shift left, u squared minus u minus 1 equals 0. And that does not factor, does it? No, it does not. That's not an open factor. If that was, there are no factors of -1. So again, I do x equals -b plus or minus square root b squared minus 4ac all over 2a. And what do I get here? I get 1 plus or minus square root of 5 over 2. What a funky looking answer. What a very funky looking answer. Now do remember, x to the 1/3 was u. This is actually u equals because it was u, not x. So it is 1 plus root 5 over 2, or x to the 1/3 is 1 plus root 5, minus 1 minus root 5 over 2. Now the opposite of rooting is cubing. And I believe that for the purpose of these questions, that's enough. So yes, I went back and I looked at the key for this, and that is the goal to get to. Get to that. And I got to stop because I got another class.